Everyone! So, today I got to deliver in my food, and surprise, surprise to every chemistry teacher everywhere, it came with some really, really cool stuff. This right here is called dry ice, and I figured I'd just play with it because chemistry teachers, right? So dry ice is CO2, same stuff that we breathe out, and as you can see, it's called dry ice because it is really cold, but no liquid is coming off, only this smoke. Now, dry ice, like I said, is CO2. It is when we take CO2 solid and we turn it into gas. But the cool thing about dry ice, as you saw, is that there is no liquid phase at atmospheric pressure. Instead, it goes through a process we call sublimation. That's straight from a solid to a liquid over there. And I'm sorry, a solid to a gas over there. And from gas back to solid, it's called deposition. So, dry ice is fun stuff. It's used in industry whenever you want to transport something cold, but you don't want to get it wet. Just so you know, and I look up some of these facts on Wikipedia, dry ice sublimates at approximately negative 78.5 degrees Celsius, which is negative 109.3 degrees Fahrenheit. Now, what I think is also really interesting about CO2, as I was saying, is that it actually doesn't form its solid phase at atmospheric pressure. You need to pressurize carbon dioxide to, I'm not sure the exact amount, but it's definitely a multiple of atmospheric pressure, something like 6, maybe 10 atmospheres of pressure to pressurize all of that gas into a solid, and you actually can't see the liquid until you hit something around like 2 atm. Anyways, what can we do with dry ice? Well, and please note that I am wearing a glove for safety. First thing you can do for dry ice, if you have a piece of metal, and I happen to have a piece of metal right here, it's not going to be the best, but if I were to put the piece of metal on the dry ice, it causes the metal to vibrate a lot, and that vibration will actually cause noise. I don't know if this is going to work. Let's try it out. I heard a little bit. I don't know if you can hear it. There it is. Okay. What else can you do? Well, obviously, it's cold, it's fun, but this is what they do in the movies. They add it to hot water. So, of course, I have here my Erlenmeyer flask over there. Inside the Erlenmeyer flask, I'm adding, this is just some boiled straight up water. Hopefully I don't pour it on myself. Ugh. Have a towel, because knowing me, I'll make a mess. That's my cat, Gus Gus. For those of you who don't know, Gus Gus, stay. Talking to him like he is a dog, right? Okay, so we have some very, very hot water. Now, typically in movies, if you want like creepy, scary scenes, you want it to be kind of smoky and dark, right? And you could burn fires, but there are many hazards with that. Number one, obviously, you're making fire. Number two is that smoke tends to, A, cause people to cough, and B, rise. So if you have all this smoke going up in your face, you can't really breathe, you can't act out your dramatic scene. CO2 gas, as you can see, is going downwards right now or towards the ground, which of course tells us that it is more dense than air. So lots of CO2 gas won't cause any problems as far as coughing because it'll be all below your face. Break it up. Break it up. Okay. Pop some in. And then you can see, ooh, I am a mad scientist. Or, right? Isn't that really fun? And I can just do this all day. I love this. Now, the cool thing about dry ice and CO2, as I was saying, it is more dense than air. You can actually pour it out. And as you can see, I now have a cup of CO2. Now, it will diffuse eventually, but it's just kind of chilling in there. That's all gas, right? I can pour it right out. Oop. Like I got a little condensation from the inside of my graduated, my Erlenmeyer flask. Add some more. keep on doing this over and over again. Now, another safety, piece of safety. Where are you going, Gus Gus? Well, apparently Gus Gus is not like that. The best thing about dry ice is that it doesn't really make a mess. It just sublimates right into the air. Isn't that fun? I could literally do this all day. Woo! Now, interesting inside of there, it is hard to see. Let's see if I can get a zoom in. No, it's not going to get on video. But if you put too cold water inside, if you put the dry ice inside of water that's too cold, it'll actually form solid water around the outside of it and freeze, and it'll actually slow down the process. You can be the viewer back there. Very good, guys. Okay. And then this one, next is everyone's favorite. Once again, I'm going to be adding my hot water. I'm going to be adding it to my beaker over here. And I'm going to make a lot of mess. The best part is that instead of just making all of that carbon dioxide, just making the CO2 actually sublimate, what I'm going to do next is I'm going to actually trap all that gas into this shell, if you will, by adding a little bit of dish soap. By the way, totally got dry ice from a supermarket delivery. I'm not saying that everyone should go out and get dry ice, but if you do ever get dry ice, you don't know what to do with it, just throw it in the sink with some hot water, CO2 will come out, it'll be fine. But if you put it into soapy water, you'll get these bubbles. Oh, so many bubbles. Ooh, and they're warm too. Now, here's the cool thing about the bubbles. As you can see, if you take these bubbles, when you pop them, pop, carbon dioxide comes out. And this will go on for, well, a heck of a long time. And you can just do this forever. I'm going to actually go run this in the sink because I'm in my apartment. But I want everyone to have a lovely night and be safe.